Factor the following completely. If the polynomial is not factorable, write prime. So now on problem number 1, maybe finally a little bit of a challenge for you. We're looking for the biggest number that goes into both, divides into both 21 and 14. And what we see is that the biggest number that goes into there is 7. Between x squared and x, we're going to take the lowest exponent. And between y and y, we're going to take the lowest exponent. So that's our greatest common factor. And then we want to finish the rest. So 21 divided by 7 is 3. X squared divided by x. We had 2 x's, we took out 1. We still had 1. We have 1 x remaining. We had 1 y, we took it out. 14 divided by 7 is 2. We had 1 x, we took it out. We had 1 y, we took it out. So my parentheses is a little bit far away, but there is the answer to our factoring problem number 1. Problem number 2, same kind of thing. What we're looking for is we're looking for the biggest number that goes into both 24 and 20. And when I say goes into both, I should say divides by both. So 24 and 20 are both divisible by 4. Between x cubed and x squared, our smallest exponent is x squared. So 4x squared is our greatest common factor, and we just want to figure out what's remaining. 24 divided by 4 is 6. X cubed divided by x squared. We had 3 x's, we took out 2, we still have 1 left. 20 divided by 4 is 5, and then x squared divided by x squared is 1. Where we had 2 x's, we took them out. What we have written here is our completely factored version of 24x cubed plus 20x squared. Problem number 3. We're looking for the biggest number that divides into 15 and 27 and 3, and that's the only place where we can get our greatest common factor because there is no x on the 3, no x value on the 3. So the biggest number that goes into 15, 27, and 3 is 3. That's our greatest common factor, and then we can divide. 15 divided by 3 is 5, x squared. We didn't do anything with the x's. 27 divided by 3 is 9, x. We didn't do anything with the x's. 3 divided by 3 is 1, and we must write down the 1. But there's our factored version. Problem number 4. X cubed minus 9x squared minus 15x. No numerical greatest common factor, but we do have an x for our greatest common factor. It's the smallest exponent on those 3 values. And when we factor out the x, we had 3 x's, we took out 1, we've got 2. We didn't do anything with the 9. We had 2 x's, we took out 1, we've got 1. And 15x divided by x is 15. We had 1 x, we took it out. There's our factored version. Number 5. This time we do have a numerical factor, greatest common factor, as well as a variable for the greatest common factor. The biggest number that divides into 6 and 14 and 22 is 2. And the variable that we're going to use is we're going to use x to the first power, that's the smallest exponent, and then we divide. And that parentheses is pretty far over there, but we'll start there. 6 divided by 2 is 3. Try this again. 6 divided by 2 is 3. We had 3 x's, we took out 1, we've got 2. 14 divided by 2 is 7. We had 2 x's, we took out 1. X squared divided by x is x. 22 divided by 2 is 11. We had 1 x, we took it out. There's our factored version. Number 6, same idea here. We're looking for the greatest common factor. The biggest number that goes into 45 and 15 is actually 15. Oops, and between the variables here, I forgot the variables for a moment, but between y cubed and y squared, it's going to be our lowest exponent, which is y squared. And when we factor that's our greatest common factor. 15y squared is our greatest common factor. So now we've got 45y cubed. 45 divided by 15 is 3. Y cubed divided by y squared. We had 3 y's, we took out 2, we've got 1. 15 divided by 15 is 1. Y squared divided by y squared is 1. We had 2 y's, we took them out. We must write down the 1. But there's our factored version. Number 7. (5x squared y minus 8xy plus 10y). There actually is no numerical greatest common factor. And when we look here, we've got an x in this term. We've got an x in this term, but there's not an x in the last one. So there's no x's, but there's a y here, and a y here, and a y there. Our greatest common factor is y. And when we factor that out, we're not going to do anything with the numbers. We're not going to do anything with the x terms. We had one y, we took it out. In our next term, again, we're not going to do anything with the number. We're not going to do anything with the x. We had one y, we took it out. 10y divided by y is 10. Again, we had one y, we took it out. And there's our factored version. Finally, to finish here, between 16 and 6 and 10, the biggest number that divides into all of those is actually 2. Between x cubed, x squared, and x, we're going to take the smallest exponent. Between y cubed, y squared, and y, we're going to take the smallest exponent. So there's our greatest common factor, and then we just need to figure out what's remaining here, and we do that with division. 16 divided by 2 is 8. X cubed divided by x is x squared. We had 3 x's, we took out 1, we still have 2. Y cubed divided by y is also y squared. We had 3 y's, we took out 1, we still have 2. 6 divided by 2 is 3. X squared divided by x is x. We had 2 x's, we took out 1. Y squared divided by y is y. We had 2 y's, we took out 1. 10 divided by 2 for our last term is 5. We had 1 x, we took it out. Y divided by y, again, we had 1 y, we took it out. Xy divided by xy is 1. So we're left with, in our parentheses, 8x squared y squared plus 3xy minus 5 to finish with our factoring.